all manner of mud. Well, where else do we see these? Well, I mean, where's it coming from? You know, there's none of these in Chesapeake Bay or Galveston or San Francisco Bay. Why here? What is it about here? This is Somme Sound again. Now, if you look at Somme Sound, here's the map of it. And they used to extend across. Presumably when sea level was 200 feet lower, this was a lake. And this was land across here. There would have been a stream coming out and it would have, you know, tumbled over some waterfalls. But as the ocean came up, the stream cut down, the ocean eroded in, just as this is all eroding today. Eventually it was breached through. So it might have been a lake. And if you go to a Cape Pond house, you're standing on a moraine, just like this, that's holding back Georgia Pond. If you go to Echo Lake, you're standing on a moraine that's holding back Echo Lake. All of the lakes there are held back by glacial deposits. This one that was near the sea was apparently breached. And what do we find out in Somme Sound, out of this area? Huge pock marks, natural gas everywhere. If you go, this is in Lubec, Maine, down east. This is a peat deposit. It's on the coast. This is a peat flat. This is nothing but organic matter. There's nothing in it but carbon. And some of it is being preserved here. If the ocean continues to rise and buries this, you're going to get a lot of carbon buried. And carbon can be eaten by bacteria and turned into methane. That's how natural gas forms. This is a picture of a large bog in Jonesport. It's this image right here. There are bogs all over the place here. And as they come near the ocean comes in and buries them. So, bogs, one possible source. Look at our coastline. It's nothing but lakes. And when sea level was 200 feet lower, this was all land. There were lakes there. There were bogs. And as the ocean has risen, they have become buried. And all of the organic matter in this wetland, and then there's nothing but organic matter in the lakes, got buried, and now is developing methane. Next. So here was my cartoon. Actually, it was just published recently. I thought someone would let me, but here's the ice age. It's melting. Belfast Bay is in the ocean at that time with icebergs. It melts away. Sea level falls to its lowest point. Lake Belfast forms in this area. There's trees. There's organic matter accumulating. And then the ocean comes in. It rises up. It's eroding the bluffs today. Mud covers this, and gas begins to evolve out and begins to carve these pock marks and continues to do so. Next. So, I'll leave off with this. Here we are. My interest in Taunton Bay professionally is what you see here. This is the reversing falls. This is the narrow part here. That's a glacial moraine. It comes across. It was a dam. It dammed Taunton Bay. Taunton Bay was not Taunton Bay. It was Lake Taunton. And Lake Taunton was back here. There was another Lake Egypt back here. And they were, just as you go along the present coast, just as there are lakes coming up from our bays, there was here. There would have been a river coming right through here. Probably not a lot of water because there's not a lot of drainage there, but it would have eroded into this glacial deposit. But it quickly would have been covered, the channel would have been covered with boulders and cobbles. It wouldn't have eroded down. It was the ocean probably acting from this side that eroded into it. And eventually, at some point, I don't know when, breached this. And of course, once the tides got at it, then it could really start to work it, and it became tidal. So if you go out here, you'll find bedrock at the bottom of the bay. You'll find glacial marine mud. You'll find, I think, a lake deposit and or wetland deposits. And above that, suddenly, probably very quickly, it was transformed into an estuary. As time goes on, it'll go offshore and it'll become a pock field, I think. So, anybody has any questions? I'd be happy to answer. I don't have a switch on. Somebody must not believe it. Go ahead.
Is the natural gas that you pointed out commercially viable?
There are places up Japan where actually fishing boats go in and they have an evacuated tank. You drop a pipe down, you can fill the tank, and then you've got a supply of methane for
I noticed there was such an indication in Frenchman's Bay of natural gas.
Oh, absolutely. In fact, I should have said it. There is, and there's a lot of it, and there were earthquakes there last year. And one thing I've wondered about is maybe the gas just sits there and is fine, because there's plenty of places in Maine where there's gas and no pock marks. Maybe it takes an earthquake, and I have a proposal in right now to go and see if areas had no pock marks but had plenty of gas have now erupted. But Friends of Taunton Bay certainly has plenty of gas. Go ahead.
There was a story a couple of years ago about a bubble in Korea Harbor.
Ah, okay.
And could this gas do that, just all come up in one bubble so that it could affect boats? And
Yeah, it's a scary thought, because you wouldn't want to be in a boat and fall into a bubble, because you wouldn't float. I was asked by the Bangor Daily News when that happened. We checked, there had been no earthquakes. All right, so there was no tsunami, there was nothing to cause that. And I said that to them. I got so much mail, like they printed my name and address. I never wanted to do that, I learned. But I did have another explanation. Why did it happen? There was no earthquake. There's no other way for that to happen that I could think of. There have been events like that in the past. Bass Harbor has had, people did send me in newspaper reports, 1917, all the water went out of Bass Harbor, came in as a single breaking wave. Now, 1917, we don't have good records on earthquakes, but it could have been something similar. Could it be? Possibly. I have one person, I gave a talk just on the seafloor in Islesboro Island, and there were, well, I'm sure there are millionaires in here, billionaires. John Travolta was there, and Kirstie Alley. But they pushed this one guy forward at the end, and I thought, this is the village idiot. No, the guy was really thoughtful. He had told everyone he saw these bubbles coming out of the bottom, and everybody thought he was crazy. But he described what he'd seen, that the water came up. He could smell hydrogen sulfide. You don't smell methane, but there'd be hydrogen sulfide with it. It seemed entirely possible to me. The harbor master in Belfast told me a number of years ago that he was diving, scuba diving, and he knew the holes. And he said the wall just blew up. He thought he was in a Coke bottle with the bubbles coming out. But when you think about it, the gas is under a lot of pressure down there deep. As those bubbles come up, they're going to get bigger because there's less pressure. The likelihood is that little bubbles are going to break and you're not going to see them. It would have to be a phenomenally large bubble to do that. I've never gone through the calculations. Could it have happened? Yes. But I don't know. I don't have a better explanation of it. Yes?
What about those earthquakes we had last year?
Well, oh, gee, I should have thought that. Okay, why do we have earthquakes? What's curious about this region, we're not in a tectonically active, this is not Peru, we don't have a subduction zone, so it's not that. What we have is, what we observe is that we get clusters. Like I mentioned, down east near Eastport, 10 or 11 events a year, little ones mostly, but the largest earthquake in Maine's history was measured in Eastport in, I think it was 1905. There's other clusters. Dover Foxcroft has one, Portland area. What is it about them? Well, when you get a large earthquake, like the one in Peru, what will happen after that is there are aftershocks, smaller quakes, and they trail off over a period of time. The model for explaining this, and it's not my work, I'm just telling what I've heard, is that these sites where we get these repetitive earthquakes had a large earthquake a long time ago. And now we're seeing perhaps hundreds, if not more than 1,000 years down the road, little events continuing, suggesting that maybe where we have these pockmark fields were sites of large earthquakes at one point. The largest earthquake measured in the United States was in Charleston, South Carolina, in the Appalachian Mountains. So it does happen. What ultimately causes it is not really well known. We're being pushed apart by the spreading of the Atlantic Ocean, and that force is somehow concentrated, but you get into the geophysics that I really can't explain to you. In fact, the matter is everybody seems to disagree when someone does explain it. So I don't know exactly why we have earthquakes here. Nobody really does. But the pattern is one of having large ones that then trail off. And that's what those probably were. What's remarkable is that they were very near the surface. They may have ruptured the seafloor, which is interesting and why I would like to go out and look. Because most of them occur other ways down and we don't see any. And you don't feel them as much when they're down from it. Could we have another large earthquake there? Geologists who study this would say, highly unlikely, but they'll never say never. Yes?
A while back, I saw a television program trying to report, decided the reason for the disappearance and crashing of some Navy fighters off the coast of Florida. And they postulated here that it happened with gas bubbles that come up, saturate the air, displace the oxygen, the engine stalled, and planes crashed.
Well,
they even postulated that one came up with the rear end of a boat, we crack the boat in half and it could sink the boat.
I don't know if it's crack the boat. If you think about it, scale it down to your bathtub, if you had some big bubbles coming up, and you had a little toy boat, it would fall into the bubble, and that'd be the end of it. When are these things likely to be active? Probably when the tide is low, the pressure's off, and there's a storm, a big storm, waves pumping it. Is that when we lose boats? Well, could a boat have gone down? Certainly possible. Offshore of Florida, though, there are deep deposits, way offshore, that methane and water become a kind of an ice called a clathrate. And there are vast deposits of frozen ice methane there, and it's very susceptible to a temperature and how much water is squeezing down. It's thought that when those things go, really large amounts of gas get up.
Which one's what they were talking about?
But yeah.
That would be much larger than the kinds of things happening around here.
Oh, orders of magnitude larger, yeah. Yes.
You mentioned John McPhee's book early on.
Yep.
Any other book you'd recommend, or your favorite book about the area that would summarize
Gee,
as well as you did?
I just wrote a book. I actually beaches. I'm embarrassed that I didn't bring it. I wrote a book called The Atlantic Coast Beaches, and I wrote the New England chapter. A lot of the cars are on Mount Desert Island. It is a book that explains beaches, though. It's only beaches. I've been going to write a book on the Maine coast, but I haven't, really isn't one quite like that. It just takes time, and at a university, we're paid to raise money, get grants, train graduate students. Writing a book for the public, isn't a priority, but I'm tenured now. They can't get rid of me, so I can do what I want. So I've been promising I'm going to do that, but I have not.
Look forward to it.
Thanks. Yeah.
Speaking about beaches, I've recently discovered for the first time Jasper Beach. Right next to it, you have these mud flats and the clambers there, and this one beach has rhyolite, it has quartz, it has granites.
Yep.
These had to come from different times, from volcanoes, from two
The
times.
rhyolite, Jasper Beach is my favorite beach. It was a beautiful beach in the Chisport. It isn't really jasper, as you say, it's a rhyolite. It's a fine volcanic rock with a beautiful reddish color. It comes from, there's a glacial deposit that's eroding right there. When you walk out onto the beach to your right, and that's where much of the material is coming from. And because it's a glacial deposit, it's a mixture of different kinds of rocks. There's granites, there's volcanic rocks, so that's where you're getting the mixture of materials that make up Jasper Beach.
So that's covering the mud flats that are out?
In fact, at low tide, if you go to very low tide, you walk out onto the beach and you go to the left. There used to be a fishing weir out there, but a rock emerges right at about low tide. Right near it, there are tree stumps from when the beach was way seaward of where it is. There's clam shells and stuff that are probably thousands of years old. I've never tried to date them, but yeah, it's a marvelous place. But you have to go at low tide to see it. You won't see it when the tide's up again.
Can I ask you a question?
Sure.
The contact zone between the Ellsworth schist, which is there, and the Sullivan granite, which is there, goes right up, kisses that point. Is there any characteristic of that, maybe a shatter zone or something there?
Okay, so we had a molten body that was coming up through the earth through much older rocks, much older. They were solid. The Ellsworth Formation was a solid rock, but it was heated because this was probably about 500 degrees Celsius. This was cooler, and so one thing happens on the edge is that there's a heating up of the Ellsworth rock. Sometimes there are places where rocks of what are called country rocks that surround the molten body fell into the molten body, and you're certainly familiar with the shatter zone on Acadia, but that's rare to see that. We think of it as commonplace. You can see it in a number of places there, but in fact people come from all over the place to see geologists to see that, because that is not. It's rare for that contact to be exposed where rocks were falling in. The reason the bay is here is because of that contact, and the reason is that along the edge here, the rocks would have been more fractured. There would have been a tremendous temperature gradient across here, and when temperatures range over a great deal, rocks can become embrittled and break. And then when the glaciers came, they were able to just clean those out and leave that as a relatively lower area. Yes?
The composition of the marine mud
Yeah.
from a much earlier period, is it substantially different from the mud that has the
methane
No.
capacity, or could the same processes have occurred much, much earlier and are just being repeated again?
They could have. I didn't go into it, I could obviously give a whole talks on that, but the pockmarks only go down to the glacial marine, they don't go into it. So we really think that the source of the gas is on the surface or above it, not actually in the glacial marine. But the makeup, modern mud, is nothing but eroded glacial marine mud. I mean, when you look at our rivers going out to sea on a muddy spring flood, that's nothing but eroded glacial material. There's no soils of any consequence forming like down in Georgia or someplace like that. We're very youthful terrain.
Well, I guess the geologist's definition of mud
It's particle size, smaller
just
than.
particle size. It has nothing to do with, I mean, we think of, or I think of mud as being organic compounds and active, but that's not, that's not the
There's
case.
no compositional meaning of sand, doesn't mean quartz sand, it just means bigger than 62 microns.
Okay.
Sand size, you can see it grain, you can actually see it with the naked eye, and that's why they picked that size. Smaller than that, it's mud. If you chew it, and it's a little gritty, it's silt, and that it works right out, it goes down to about 2 micron. If you can't chew it, it just kind of, I don't eat a lot. If it doesn't crunch at all, it isn't gritty, it's clay, and then that's 2 microns. So there are very rigid definitions on the sizes, but they always reflect some, there's a reason for it, that people pick those sizes, and it's not a modern reason, it's a very old reason.
I think we got to wind it down, maybe a couple more questions if you still have.
Sure, go ahead.
This whole business of building the Wisconsin rights over something that's at 16,000 meters.
Yeah.
100 meters of sea level rise. This doesn't, how does that on a global scale fit in with what you told us about now, which is down and up business as a
Good
rebound?
point, good point. We live in not a unique place, but a very unusual place in that the glaciers completely covered us and went out to sea, but we're still on the edge of the coastline. If you go to New York City, where the ice came right to Central Park and never got any farther south, the ice was very thin, it didn't push the crust down at all. In fact, it was probably pushed up by the weight of the ice behind it. So you won't find there, sea level was way off at the edge of the continental shelf, 300 feet deep. It's only in places in Maine where the coast comes way into the interior that lets, the ocean come way in and drown the land. Most places in the world experienced a complete lowering of the ocean, 300 feet, and then a following rise. We're not unique. Puget Sound, there are some places in Alaska that have glaciers today. Glacier Bay, I was there to actually measure the rate of land coming up. It's coming up a quarter of an inch a year. It's just remarkable over a period of time how it's changing. So you have to go right where the glaciers were and actually into the interior as far as you can. And as things are changing now, and we're still experiencing sea level rise, Newfoundland is still coming out of the land is still rising. Hudson Bay is rapidly rising. I reviewed a paper recently on Finland, and it was a history paper, but I thought it was a great paper, about this town. It was called Harbor Town in the Middle Ages. But Finland is rising out of the ocean, and they couldn't use it as a harbor, so they moved closer to the ocean and called it New Harbor Town. But then, over 100 years, there's new Harbor Town, and that's how all of these towns track to the ocean, because they're trying to stay, in deep water. So that's an unusual thing, but it happens to be where we live. So it's kind of, I've taken people from every country in the world on field trips around here, just because it is such a special place to see that. Yes?
Could you just explain why Stone Sound was a fjord, but now it's not a fjord?
Well,
Is that just interpretation, or is that?
if you've seen a fjord, if you've seen a real fjord, like in Norway or Glacier Bay, okay. Real fjords, it's a glacially deepened valley. In Scandinavia, where the word fjord is, they are deep. They are at least 1,000 feet of mountain and often going down 1,000 feet. So they are phenomenally deeply eroded. Stone Sound just isn't anything like that. The word they use in Sweden to talk about their coast, they don't have fjords, they have fjords. And it means glacially deepened, but not really deep. So Stone Sound is probably closer to that. It just wasn't carved deep enough, or the mountains weren't quite high enough for that to happen. Go to Newfoundland though, and you'll see.
How deep is those,
Some Sound is not really that deep, except from the water surface to the bottom, in the bottom of the deepest pockmark, it's probably 150 feet maybe, something like that, I'm guessing, but something like that. So it's not 1,000 feet by any means. Yes.
Have you taken the next step to look at soils that are more on the surface or down to some measurable length related to the geologic history? I mean, around here we seem to have a lot of gravel and
Sure.
eskers or,
Well, probably in some places.
and then you've got the beautiful deep soils of Aroostook County that
They're not that deep. Go to Georgia, they're hundreds of feet thick. Aroostook County, they're that thick. But they're better than we get in other places. It's all relative, I agree. Marine clay actually makes really good soils. It's among the best. No, we live in a youthful area, but it is remarkable. The glaciers didn't remove everything, and I took the slide out, I didn't show it. But there's places where the old soil that was here before the Ice Age, it formed over 100,000 years, it must have been really thick, is still there. You can see it. There's a gravel pit in Gardner Lake with glacial till over this red stuff. You go up, it looks like a reddish rock, and you hit it, and it just crumbles in your hand. It's a deeper part of the soil. And there are lots of those. They're called rotten stone by contractors in Maine. When they're digging, and it looks like a rock, and then you can shovel it. But they're relatively rare, and they're usually under till, so it's hard to see them, except where gravel pits intersect them. But our soils, I have worked on them, looking at the minerals that make them up, but they're really just recent, just being derived. Our rivers, I didn't say this, but the Penobscot River is the youngest river in North America, probably. It's just formed. I mean, just yesterday, there was never a river in Bangor, Maine. The real river valleys were filled. They were deep valleys. They were filled with glacial deposits, so there's no rivers in those. And there's aquifers, though. That's where many of our large aquifers are. But the rivers were just kind of dropped down randomly in the landscape, and never were there before.
On behalf of this appreciative audience, I want to give you a t-shirt. One size fits all. The only size I will just say, like a good minister, if you have extra money in your pocket, you can appreciate this free lecture by giving what you think it's worth. Thank you.
Steve, yeah, I asked that for people who did not sign the guest book, please do on their way out. We'll be here on the.
Are there any who haven't signed? Latecomers?
come up here.
Okay. Yeah, we'd like to have your contact information if that's possible.
Thank you.
I just think 2 months ago this would have been possible because we didn't exist.
That's pretty amazing. Thank you.